Okay, let's get going. Brilliant. I think we're there. Okay, hello everybody. This is a little impromptu do we're doing today. Lucy asked me to explain what we're doing in our London group, which we set up after last year's event, which is Piers, myself and a couple of people who were at the Bath side of the event but couldn't make it here today, but we can hang on really nicely. And rather than just explaining what we're doing, I decided to actually do a live demonstration of exactly what we do once a month, which is invite people in. We've had Wellin and various other people, and from all over the world. So we make it international, then we stream it out through Facebook, which seems to have frozen. So let's just have a look at that.
Well, he's blinking.
Yeah, no, I'm talking about the Facebook feed. That's frozen a bit, but so I don't know if anyone else can actually
Click on start watch.
Oh, there we go, there it is. Oh, okay, I'm frozen. Sorry. Oh, so yeah, so rather than actually just explaining what we're doing a live demonstration, and as you see, we've got Don Scott join us all the way from Arizona. Okay, enough.
Here's Terminal.
Hello!
Yeah, so we've got Piers. So what we're going to do is we're just going to, because Don is obviously the expert on Birkeland currents and he's modelled them from a mathematical position, we're actually going to start with James, because James has actually modelled them as a 3D graphic, and so we're going to let James go through them, and then I'm going to hand you over to Don, and James and Don can have a little chat together about it and about your Birkeland current theories, and yeah, then we'll go on from there.
Where's the...
Right, hold on a second. Sorry, you might have to do that again. Yeah, sorry, again. Yeah, move it, yeah. Okay, so it says typing interest because James has built this 3D model of a Birkeland current, and his basically we have it up on the there it is, and basically he can tell you all about it and how yeah, how he come to do it along with Don. Carry on, James, if you're ready.
Yeah.
Yeah, I will do. I'm not going to stand up all the time. This one makes sure everything's working.
Okay. So Donald and I worked together to create this simulation of the Birkeland current. And you can see it moving here. Up on the left we have the mathematics that's behind the Birkeland current. It's called the Bessel function, and definitely Don will have to explain that to you. And I'll just run through really quickly and show you what this does. If you start in the very center of the Birkeland current, this is called point 1, and I've just highlighted just the very center. You can see that the current is moving entirely in the axial position to the right. There's no rotation. If we look at the Bessel function, you can see that in there. The black line, the solid black line, is at 1. That means that it's at the full axial direction. And the red line is at 0, and the red line is the rotation. So at point 1, which is where we are right here, I'll just scan through and let you see that I can scan through and show the different points. At point 1, it's full axial, no rotation. If I move a little bit across, the black line starts to drop, which means the axial decreases a little bit. The red line starts to increase, which means we start to get a little bit of a rotation. So this would be point 2. I move on across, well, not quite point 2, this is actually in thirds. Move a little bit further across, the rotation is increased even more, and the axial is now decreased a little bit. When I get to point 2 now, you'll see that it's entire rotation. There's no axial component. There's no current going in that direction. We move on across. We're starting to now come backwards. The axial is now coming toward us because the black line has now gone below 0. And the red line is dropping down. We get a little bit more rotation in that same direction. And finally we get to point 3, and now we're at a full negative black line, so now the current is coming back the other direction, and we have no rotation again. We continue on. Now we're actually rotating in the opposite direction just a little bit, but we're still largely axial. Move on across. The rotation's increased even more. And finally here at point 4, you can see that we have full rotation in the opposite direction from what we had earlier with no axial component. Finally we get to here, we're starting to move again axial, back in the same direction that we had started at. And when we finally get to point 5, we've now completed the cycle. We're now moving in the very same direction we were initially with no rotation. And this is based on this function, the Bessel function. And this is actually one cycle, you could call it. In looking at Jupiter, we believe there are 14 of these, so we would continue to keep growing these through more and more cycles.
This is just about what's happening along the axis, is it? And then you've got other currents outside.
This is the Birkeland current. This is along the axis of the Birkeland
Okay,
current.
but because you've got these other colours, these are you're going to talk about.
The colors are just to make it easy to distinguish that these are different cylinders. They don't mean anything.
Okay. So, but we're talking about the centre one right now.
Right. Well, we're talking about the whole thing right now. I went through all of them just now.
Oh,
That's
okay.
concentric.
So this program allows you to rotate it and look at it. There's kind of a glitch in the program, but it's kind of nifty because this is what we really have going on here, right there.
Wow.
So that's really all my explanation. I'll let Don take it from here and explain what he's got going here.
Okay, thank you, James. Well, all I can say is, in my best British lingo, I would say spot on. That's exactly what I would say if I were there. Just one clarification, that is that these various cylinders, these various cylindrical surfaces that you've shown, they're sort of, as each one of those is sort of a milepost as we go out in radius. So on that graph that you showed, the graph of the Bessel function, the horizontal axis is the radial distance out from the center of the cable. Does everybody understand that? Because that's crucial to understand what's going on.
Oh, I see.
So this is the minimal radius.
The Bessel function describes the axial component and the rotational component as a function of radial distance from the center of the current. Everybody cool on that?
Yeah.
The only point that I would make is just to emphasize that these various cylindrical surfaces, as I say, are sort of waypoints, markers. As you smoothly increase your radial distance from the center, those lines smoothly rotate. There's no. It looks like in your model, in James's model, and I fully agree. That's the only way you can show it, is to show these different surfaces. But you have to realize that in between those let's say adjacent surfaces, there is still current moving, sort of in a gradually increasing. It goes gradual increases and changes from one of those surfaces to the next.
So it's a
as you go
continuous
out in radius.
connection. It's not sliding.
Whether that's clear or not, I don't know.
Excellent, thank you. So I'm just adjusting the lighting for a bit better for the old Facebook. Cheers, Don. Yeah, this is quite revolutionary, really. It's to actually. How did you come to realise this was happening from the original model?
Oh, well, the genesis of the original model, everybody's been working on that for years. The first guy who tried this was Stig Lundquist. And back in 1950, he came up, he laid out the same ideas that I used, which is that it's sort of a mathematical equivalent of saying water runs downhill. And I think Philip was saying, well, at least he said it in his note to me, that he thinks that everything follows the path of, quote, least resistance, unquote, and I agree completely. You know, if you let it alone, what will it do? If you don't poke at it, if you just sort of throw it out in the room, where will it go? What will it do? And if you just make that English statement into a mathematical statement. It gives you an equation. If you solve the equation, this is what comes up. Stig Lundquist actually got the two Bessel functions, and then he, being sort of a mathematician, he said, "Oh, that's it. That's the answer," and he dropped it and went off. I, as an engineer, asked the question, what physically do those equations, those two Bessel functions, imply? What does this structure look like in three-dimensional space? You can't just write down two Bessel functions and say you've solved the problem and leave the room. And I think as an engineer, I've tried to show what James has actually done, completed my job and actually shown what the results of that work are. So it's a sort of a continual work started by Birkeland himself back in 1908 or whenever it was, when he said, "Hey, it's stuff coming from the sun, charged corpuscles coming from the sun." Then Lundquist picked it up in 1950. I picked it up in, well, about 2015 or so. And then James got into the act, and here it is. This is the final result that I think makes it such that a human can understand what's going on.
Yeah.
If you think about this model, just try to visualize what the end of this model looks like. It's a bunch of sort of concentric, sort of almost looks like a target, bullseye. And when this kind of Birkeland current impinges on the north pole of a planet like Earth or Jupiter or Saturn, what you're going to see are these counter-rotating cylinders. And we do indeed, I think I'm very proud of the fact that, I think it was in 2015, I'm not sure, it was one of the EU conferences, I made this point that there should be counter-rotation. And it wasn't until about a week later, NASA published their first video of the North Pole of Saturn, which is the classic counter-rotation. You just look at it, and NASA was all stumped. They said, "Oh, there's a hurricane, a serious hurricane that's locked to the." I'm sure Piers will get a kick out of this. He said, "It's a hurricane, but on the idea, it can't be locked in position, and it has to have hot water underneath it to supply the energy for this, as all hurricanes do. When hurricanes go over land, they fall apart. So this one didn't fall apart. It's and it's been locked there ever since we've been able to look at the North Pole of Saturn to see it. So, and then Jupiter, the same thing. And James said there's 15 of these things, 15 of these counter-rotating cylinders on the North Pole of Jupiter. And we've begun to see them even on Neptune. And so I'm very happy. My latest job, and I'll shut up here in a second, was that I got across this, onto this earth.nullschool.net website.
Brilliant website.
And it shows, it's a combination by I think it's the U.S. Weather Service and a bunch of other, there's a European weather outfit in there as well. And they show what the outer atmosphere, that is the wind currents, look like on Earth. At every point on Earth, at 10 hectopascals, that's 10 millibars, I guess, which is pretty high up there. And they turn out to be almost perfectly circular, and they are counter-rotating. And so I said, well, that seems to me like supporting evidence for this idea of what a Birkeland current is doing. And so anyway, my latest, I just talked to Michael Goodspeed about a space news that should be coming out in the next few days, that there is now, we've discovered, there is a yearly periodicity in the Birkeland currents that go down into the Earth's poles. And they actually switch direction. The rotation switches 180 degrees, goes back the other way every 6 months. And so nobody knows all the details. Ask me a question, and I guarantee you my answer is going to be, I don't know, on most of this stuff. But we're beginning to see the hard data that this model, this Birkeland Bessel function model, indeed is correct, and we've got 2 or 3 different places now where we've seen the effects in real life. So
Well, we're seeing.
if I can
that's
answer
fantastic.
questions, I'll be glad to answer. Go ahead.
Yeah, well, what I'm saying is because it's going the opposite way, that suggests it's an actual circuit rather than a power dump in one direction, yeah?
Say that again, Phil?
Because you've got rotating cylinders going in opposite directions, that would suggest to me that it's a circuit within itself rather than a power dump in one direction. Or it
Yes,
needs that
right.
circuit to actually
Brooklyn
transfer
current
it.
will carry currents in both directions. There's an example of that. An example of another example of a Brooklyn current is this floating water bridge
Yeah,
that I think Jerry Pollack showed and several other speakers have shown at our various conferences. And there's one video of this. You know, there's 2 different beakers of water, and you put a voltage across between the 2 beakers, and you slowly pull the beakers apart, and the water forms a tube. And it's amazing. You can't believe your eyes when you first see it. What holds that water there? I mean, it's suspended in space. It's like a suspension bridge, but there's nothing there but water. So why? Well, because it's a Birkeland current, and it's the strength of this counter-rotating sort of twistingness that makes it that way. And in this film by the Russians, you can actually see the tiny little bubbles going in both directions, so we know that there's a current flowing,
You mean
the
there's
possibility
a,
at least.
there's a physical
current
water
in both
current flowing as well?
Same
isn't there?
time.
Well, it's the currents flowing through the water.
Yeah.
So it's very much, the water's not moving. It's,
Well, is the water moving or is it not? He said bubbles.
No, yeah, the water is moving in from one beaker to another. Because
No,
one of the
I know that,
examples is
but going round and
if you
round.
put ink dye in one of the beakers, then all of a sudden, I shouldn't say all of a sudden, very, very slowly, you begin to see the green shade going across the bridge into the other beaker.
Okay.
And then if you pour red dye into the second beaker, very slowly you'll see red creeping back into the first beaker.
Oh,
So
oh,
it's
really? That's
pretty much
interesting.
possible.
So that's
Those
a
go both
longitudinal
directions.
motion as well.
So just say it again.
It's a longitudinal motion along the line of the
Bridge.
axis, along the axis. In an axial direction.
Yeah, the flow
Yeah,
is
in a spiral
is in-
direction. Okay.
there is the most powerful, the strongest flow is right near the axis, and that's in the direction, that's the nominal direction of the current. And then if you go out, as James showed,
Yeah.
a couple of those discs out, you can see there's an absolute reversal of the flow, and that will be the other flow coming back in the other direction. And as James also said,
Yeah.
if you continue to put more and more and more radial layers on this, and there's no limit to how many layers you can have. As he said, in Jupiter there seems to be 15 of these things, 15 complete cycles, so that you can see current flowing in both directions at various levels. It's sort of like you visualize a coaxial cable. Well, this is not just the center and the braid around it, but then outside of that there's another braid and another braid and another braid and another braid, and current can flow.
So you say you can have as many as you like. I mean, but
Right.
it has to stop somewhere. So you can easily go to 10 or 15. I mean,
Well,
you
you
can
can-
go to 100. I mean,
Well, if you look at a galaxy, which are threading galaxies together, they must have quite a few.
well, maybe, or maybe only 3. I mean, I don't know.
Yeah, well, yeah, yeah.
So,
But you don't have to stop it anywhere either, going outwards.
so we have a question from Michael Claridge here.
Hey Don, can you hear me?
Michael, I can certainly hear you.
You wanna come to the front?
I wish I were with you.
I wish you were here too. I'm trying to bring in. It seems to me that the amount of shells, the number of reversals, or the number of coaxial shells should increase with increasing energy transfer or with increasing current. But I just want to know if you've thought about that at all in any way to start with the equations or interpret some of the parameters in the equations that would help me think about how the number of shells is dependent upon either the energy or the current transfer.
That's a great question, and the answer is I've thought about it a lot, And I don't know, I don't have any specific answers. I will say that, you know, the parameter that everybody focuses on in those Bessel functions is alpha.
Right.
And if you read that first paper, the alpha is really a scale factor that says the Bessel functions come with their own natural abscissa variable called x. That's it's like the radius. How far out are you? What's the value of x when you go out to various shells as x increases? Then when you're actually thinking about making this model, like any model, a ship model, you want to make a ship model of the Ark Royal aircraft carrier, okay? Well, the Ark Royal is about 900 feet long or something. Well, your model is going to be maybe 2 feet long. Well, this is a scale factor between 900 and 2. That's what alpha is. So I guess the question I'm agreeing to ask myself, and I'm saying I don't know the answer to it, is what determines alpha in any given situation? What determines how many rings there are going to be? Clearly, it seems to me that I think most people will agree that the Jupiter, the biggest planet, has the biggest magnetic field in the solar system, and it probably has the biggest, most powerful Birkeland current leading to its poles. And it has 15 layers. So I suspect what I think you said is correct. That is, the more power that this thing is asked to transmit, the more current it's asked to transmit, the more layers it's going to have.
Right.
But exactly in any one situation, how does that? What determines, like in the Earth? I think that we see a center lobe and maybe one outer lobe.
So,
And it's the Earth's weak one, I guess, compared to the ones to Saturn and Jupiter. But I think I told you guys that when I first submitted that paper for publication, I submitted it to the IEEE, and they rejected it because clearly I didn't understand what alpha was. They said alpha is a property of the plasma. And I said, no, it's not. It's a scale factor. And if you do you think that every Birkeland current has the same diameter, the same size? Of course not. It's the difference between, I think, physicists and electrical engineers. That is, engineers like me are very eager to talk about models. And the physicists, they don't want to talk about models. They want to talk about, this is how God made the world work, and this is the equation that tells you how it works. Whereas I'm saying, no, this is a model of one of the things that is really in the world, and there are all sizes of these Birkeland currents, and alpha is the scale factor that says how big is the one your particular problem is working with. Is it the Saturn one? Okay, that has alpha is such and such. If it's the Earth one, alpha is much larger. That says the scale factor is much smaller. I don't know whether I've run off at the mouth here, whether or not I've answered your question, Michael, but I don't think that's one of the good questions about how big is this thing and what determines how many rings there are. And you and I have discussed this before, and my answer to most of the questions is, well, how do you know how far out the thing goes? And I think my answer is, well, until you run out of charge. And there's a certain finite amount of charge that's being transferred from one point in space to another. And if it's a lot of charge, well, there's going to be a lot of sheets. If it's not very much charge, it might only be a center.
Right.
But nobody knows in any particular situation. I think what future research might be is to say, okay, we go at it the reverse engineering way. We know how many amperes go into Jupiter, and we know how many shells there are. Now, do we know how many amperes go into Saturn? And there are fewer shells,
Right.
less current. So what's the ratio between the total number of amperes or kilowatts or whatever you want to measure, and the number of rings?
Exactly.
We don't know that yet.
Yep.
Don, I don't know of any power company that has the contract to run these currents in between galaxies, and I really don't know how they maintain them. Can you speak to the Lorentz forces in your most recent paper, talking about how these are self-organizing? They have to be created just by the laws of what's happening here.
Yeah, just a word or two. You said it correctly. I think that they are self-organizing, and there's a built-in self-sustaining mechanism, and that is, it's too complicated for me to do in this kind of situation where I'm waving my hands and talking and nobody's understanding what I'm saying. But there is a self-organizing aspect to this thing, and it's very, I think the analogy is, if you're on the top of a mountain and you got a bucket full of water and you spill it, what's going to happen to the water? Well, it's going to trickle off in about 100 different trickles and go down the hill. What determines what direction the trickles go in? Well, the trickles will follow the negative of the gradient of the slope. I mean, they go down the steepest one they can find. If there's two pipes leading down, one is steep and one is not steep, most of the water will go down the steep one. It likes to go down the chute. So there's this. That's the aspects of this thing that it's. All I can do is I can say, yeah, there's a paper I've written, and I'm going to try to get that published too, that talks about this self-sustaining aspect of it. The answer is, I'm sorry, I'm running off the mouth here too much, but if you could picture yourself at the center of this Birkeland current, you shrunk down to a tiny little atom and big, and you're looking out from the center of the Birkeland current, outward. What you will see as you progress to greater and greater distances, the axis now, the center line is behind you, it's at the back of your head. You're walking away from the center and walking out. What you will see is that the lines, the current streams, the magnetic streams, they're all parallel, will be, let's say at the beginning, if you say the current is running from right to left, okay, you'll see it right to left, and then you'll see it begin to drop down. Instead of being at the 3 o'clock position, the 9 o'clock position, it'll drop down to the 7 or 8, and then the 6 o'clock position, and then as you increase your distance away, this rotation of the twisting continues smoothly, not in abrupt jumps, and it continues smoothly and will continue to rotate in a counterclockwise direction, okay? So what that means is, if you are a current, a piece of, a charged particle, and you decide, oh, I'm not going to go at this radius, I'm going to jump out to a larger radius, what I've shown in this paper I'm going to try to get published, is that a Lorentz force will take that particle and shove it back to a lower radius. And it's because of that continual increasing of the rotating field as you go out, increasing your radius from the center of the axis. It's complicated, I know, but that's the best I can do at this point.
Oh, thank you, Don. Michael, you've been building a solar system down in down the bottom, TRAPPIST 1, was it?
Yes.
And can you tell us a little bit about your what you've discovered from it?
Yeah, so some of you, I'm sorry, I probably should have made sure it was better known in the group here, but I've been building wire models of entire solar systems, and to study the electrical aspects. A lot of us have heard of the idea of a transformer or a resonance, so that if I have an electrical phenomena over there, like an antenna or something, and I'm sitting over here, and I'm a piece of wire or an antenna, I will receive those signals and I will resonate, I will vibrate, I will be in resonance with the signal. So in a solar system, the idea is that the sun is the only source of power. That's where all the vibration, all the variation is coming from. And then I build the circuit around that to see how the planets respond to that center core. So in electrical language, it's a center core transformer that I'm building the solar system as. And part of the motivation is that our sun flips its magnetic polarization every 11 years. And that really kind of is, by definition, what a transformer does. The one side, the power side, flips its magnetic orientation back and forth. And that's how all of our power grid has been working for the last 100 years, is on that one principle. So last year when I was here, I built our solar system and found the resonant frequencies of our solar system just according to the scale proportion between the orbits. And this year I wanted to build a different solar system. So you may have heard of TRAPPIST-1, which is this famous exoplanet system where we've actually mapped out 7 planets that go around TRAPPIST-1. So I built the model on that with those proportions because I wanted to see if it was the same resonant frequency as our solar system or not. And of course it's not. So it's a different set of resonant frequencies for TRAPPIST-1, which is very exciting. And then a second result that came literally just the last hour or two, I took away all the planets except one. So I only have one planetary coil in this transformer. And I measure what frequency it wants to vibrate at. And it wants to vibrate at a certain number of oscillations per second. And I take that planet out and I put in a second one. And I see what does it want to vibrate at. And it wants to vibrate at a different frequency. So I map that all out. And then, when you put them all together, they all shift their own individual resonant frequency to some other nearby frequency so that they can all, as a group, so that they can all resonate together with the same set of group frequencies. I thought that was pretty cool.
So what can we learn from this, do you reckon?
I think just what I said.
So are we going to be able to, in the future, predict how many planets a system has?
No, I think it's more, part of why I'm looking into this is this idea that solar systems form through electric forces.
Right.
And then once they're formed, then gravity, so to speak, takes over. But that solar systems don't form through gravity. So one of my motivations is, well, let's start studying the electrical structure of a completed solar system. And then I personally believe that TRAPPIST-1 is very small. The entire TRAPPIST-1 system would fit inside the orbit of Venus, of our solar. So my personal intuition is that it's a young solar system. It's a small, young solar system, and that solar systems grow. Just my own intuition right now, right? So I'm really just kind of hunting around these notions and trying to explore, and I just feel so grateful to be in the garage down here, you know, with 2x4 and wire. And
you and the horses go well together, Mike.
Yep.
Yeah, so do you have any... Oh, sorry.
Oh, well, so, I saw how you took them apart.
Can you speak up, please?
When they're born, your system, do you envisage that you start with like one planet popping off the sun, you know, getting expelled or whatever electrically, and so then that sings it on resonance, and then another one pops off, and then it adjusts multiple times like that?
Yeah, so that's certainly an option, but now I'm thinking more like embryonically, in the sense of there's always a whole, say you're looking at a horse, because there's a beautiful horses here, looking at a horse fetus, it's always an entire horse fetus.
Yes.
It's not like the leg pops out, you know, and then the head pops out. So I don't know the answer to your question, but I think it's more just the whole thing is developing always with all the pieces in place. So there's always 9 planets if there's going to be 9 planets.
Actually, embryonically, yes, the head just does pop out.
But it's not like you have okay. But see, but we could talk later.
Yes.
Okay, maybe we're saying the same
You'll
thing.
be fishing and you'll get a Chinese twin, you know, so.
So going back to Don...
Oh, look at that! Don sank.
Oh, wow.
I love it.
That's different. Okay, well, we won't be going...
Who would have thought
that
we would get
No, I don't think so.
some little elevator music?
Well, I had a question for him, but
Okay, well, he seems to have disappeared. Okay. Wow.
can you rouse him?
What do you think of Michael's model, his solar system model?
Well, I'm interested to see what he finds. Did you try the last one with the looking for a random system?
Yes, and that. So Wall is asking. I said I wanted to randomize my model just to make sure I wasn't somehow measuring. I don't know what. And so I just kind of made up some orbits that had nothing in common with each other, put them in a system, and I did find. That's when I found that each one was on its own, that they didn't sync up, and that's what then led me to explore that last thing I just said about them all syncing up together. Yeah.
So you might have to redo the solar system, probably. Anyway, or did you already do that?
To look for what?
Yeah, each planet on its own.
Oh, I don't need to do that.
Okay.
Now, obviously, we have Birkeland currents feeding suns. Someone asked me earlier whether you can actually detect the sun's going in, the currents going into the sun. So, have we actually found currents going into the sun, magnetic fields or X-rays? I mean, can we actually prove that suns have juice going into them?
We have found some of those ones.
Yes, well?
Yeah, yes. I mean, the data from SOHO indicates there's spiral vortex-like currents and magnetic fields going into the North Pole and South Pole of the Sun, both.
Yep.
Right.
Brilliant.
Yeah, a question over there?
Michael, you
You're
mentioned.
first.
Oh, me? I'm not sure.
Yeah.
Michael, you mentioned that when the planets were in a certain proximity with each other, that they begin to shift their inherent resonance or frequencies and resonate together and sync. And I'm wondering, did you ever try that with maybe like 2 planets or 3 planets to see if one influenced the other's frequency, or was that only all of them together as a planetary or a solar system body?
Yeah, I just did the two, just separately, and then as a whole.
Do you think it's possible that one could influence the other if there were shown to be Birkeland currents directly connecting those 2 planets at all?
Don't know.
Well, this is what we're hopefully going to find out. Such things. Piers.
Yeah, Don, yesterday, unfortunately you weren't here, but I gave a talk saying that we have these predictable things in weather action of R5, red 5, red 4 periods, and we're in one now, actually. And I said that it might be that the Birkeland current connections might actually be more important than what looks like a sort of direct solar wind effect, or that probably things going in parallel. And we predicted there'd be new sunspots now, which there have been, and there would be more storms and more earthquakes and so forth, which have all happened, so I'm very pleased. But what I want to know is, can we actually see, I mean, you know, whilst then we got evidence of them, but can we see these Birkeland currents in real time? Because that would be fantastic if we could, and keep them on display. You know, Birkeland currents coming into the Earth's polar regions. Can we see them in real time and make?
Yeah, I can answer that one.
Ah, brilliant.
Yeah. So the Iridium satellite cluster, part of what it was equipped with was magnetometers, and somebody figured out the answer to that they can do just what you said. And I think they're refinishing all the new satellites, so the data may not be available right now for the current, but it'll be rolled out. And as Don was saying, in quiet times, the Earth just has one flip there, one coaxial set.
One coaxial set.
And then during high energy times, when there's more energy impinging,
like now,
then you see that grow into 2, 3, 4, 5, 6 of these coaxial layers.
Fantastic.
And they're of course, it's beautiful to look because they're much messier than that, and then you realize, well, of course they're going to be messier than that, right? But you can see the same structure. When you know to look for it, you can see the same structure.
Well, that is fantastic, because on weatheraction.com now we have a 24/7 recording of reporting of geomagnetic activity, solar wind, everything is on there, and we'd like to add on it Birkeland currents.
Yeah, I can.
And then show,
I can point you towards the data
that's
for that.
That's fantastic. You could help me fix it up, and it would make weatheraction.com even more exciting if you want to visit it.
Yeah.
Could I make a comment?
Sure.
When I see that pattern on your coaxial representation, I've seen the same pattern on Frank Chester demonstrating a model of the heart as a vorticer. So I've just put that out there.
Can we have a link to that?
Frank Chester, the Chesterhedron quote, and the heart and the planet, it links. It's interesting.
No, actually, no. If you mention it, then we obviously want to see it. So
I could look it up and find the timing on the video and let someone know, lets everyone know. Because he does remember.
Oh, well, we've got to close pretty soon, so just last couple of questions. Okay, Andy?
Yeah, I'd just like to second that about Frank Chester and the Chesterhedron, because I've been looking at that too as far as the internet. What he's discovered is the simplest crystalline form that is dipolar. So it's a natural dipole that forms. And anyway, you've got to watch his video. He shows how the construction of this dipolar crystalline structure takes place. And then he shows how it takes on an organic form that then can be, basically it has the wrapping currents, like the muscles of the heart. And it forms basically this structure.
Well, that'd be interesting. If you can get the link to me, I'll get it up on the Facebook group and we can all have a look at it.
I'd like to really quickly point something else out too, because this pertains to what my talk was the other day. The hyperboloid structure and toroidal outside of a mesocyclone is the first four of the vessel structure. The first four currents of the vessel structure.
Neil?
It's a question for Don. Just looking at James's model here, what I see, and you might want to comment on this, it looks like an alternating current that alternates with respect to radius instead of with respect to time. What does that say about the net charge transfer and the net energy transfer that would occur in these currents?
Did you catch that, Don? Yeah.
Not really. The connection, the bandwidth is getting down to about 3 hertz, I think now. And you were talking about the energy transfer, but that's all I understood.
Did you get
say it again?
It seems to. Am I correct in? I see this as a current that alternates with respect to radius instead of with respect to time. Is that correct? We've got current going one way and then another. It looks like AC, but not with respect to time, but with respect to radius.
Okay, I'm still not sure I understand the question. Let me make a comment, and maybe it'll answer the question, and maybe it'll be totally a question. I don't know. There is no such thing as AC. But AC, whether it's 50 hertz or 60 hertz, is due to, it comes from the fact that it's the projection of a rotating cylinder. It's a sine wave, and it's the projection of a rotating vector on a rotor of an AC generator. That's the reason we have AC. I mean, Tesla was great in saying that, yeah, we can use that, and it's going to be more efficient than DC because we can use transformers, and all correct. That's right. But there ain't no rotating, as far as we know, big General Electric steam turbine generators out there in space rotating around at either 60 hertz or 50 hertz. There are mainly DC, mainly directed currents that do indeed fluctuate. So you can think of them as a DC with an AC component floating on top of them. That's legit. But there is no such thing as an alternating current. Having said that, I will say that to get back to my latest kick on the Birkeland currents, that feed the Earth, and I tried recently to see if they do change direction, and I said earlier, they indeed do. They change. The periodicity is like once a year. And it's an interesting sort of minor result. You're the first to hear it because I just thought about it and kind of came up with it a couple of days ago. And that is that the Birkeland currents that feed, let's say, the North Pole. When the Earth is at its perihelion, that is when the Earth is closest to the Sun, it's about 3% closer than it is at aphelion, that its farthest point. Wall has said, and I agree completely, and I agree with him, that if the Earth is in an electric field, mainly due to the Sun, if the Sun is indeed charged positively, fairly high voltage, as if the Earth approaches the Sun slightly, it will be in a region of higher voltage. And from the way it looks to me, from the data I've gotten from the earth.nullschool.net, that is the Birkeland current that is, let's say, coming out of the pole of the Sun, on South Pole as well, it dumps charge, dumps positive charge out of the Earth when the Earth is at its closest approach to the Sun. In other words, if Wall is right, and I'm right, that the Earth is at a higher voltage region, it has a natural tendency to pick up positive charge when it gets in closer to the Sun. The Birkeland current is a sort of a neutralization, kind of a negative feedback control loop, if you will, that dumps that excess charge. The opposite happens when the Earth is at its farthest point from the Sun, which is typically the 4th of July. It's easy for Americans to remember that date. The 4th of July, that's when the Earth is farthest from the Sun. It is at a lower voltage, and you would think it would be getting rid of any positive charge. No, from what the data is that I see, the Earth is collecting charge from those Birkeland currents. So it acts, the Birkeland current, it's a long way of saying, the Birkeland current acts to counter any electrical effect of the Earth approaching or getting farther away from the Sun in its slightly elliptical orbit with 3% difference, which is not very much, but it's enough. So that I think what Michael just said is that these things, these solar systems may form mainly due to an electrical influence, but later on that electrical influence dissipates, is taken away, and gravity takes over, weak as gravity is. And what the recent study has shown, to me at least, is that's right, that if you wait long enough, all the electrical effects are counteracted and neutralized. And the Birkeland current that goes into the Earth is a prime example of that.
Well, I think we've come to the natural end there, right, and that is absolutely fantastic. I think a big round of applause for Mr. Thomas. Okay, Facebook and everyone out there, thank you for joining us, and we'll see you again soon. And see you again soon, Mr. Dr. Donald Scott.
Bye.